wait for that particular check to match for in
It should
the
still work.
TinyDB.
Yeah, even if it's not, even if the timer has stopped, when your other screen is active.
That's why I want, because I don't want to be wasting time checking the database over and over again.
It's
while
not
I'm
going to
on another
be
screen.
that bad. I mean, no, it's not going to be that bad. Okay, so we'll go ahead and take a look at that issue. It's really good, because it's problem solving and it's also using the tools that we already have. Okay, so it's basically a good discussion right there. So what we'll do today, my virtual machine is running in the background and it's still trying to decompress the entire Android development kit. So instead of waiting for it to finish, I'm going to start with a little session about how do we know that a screen has closed. Okay, in App Inventor 2.0, because there was a bug. Remember, we talked about that bug. The event of other screen closed doesn't work correctly. The event gets triggered right away. As soon as you open the other screen, that event gets triggered. So there's no way for you to know whether the screen that you have opened has closed or not. That's just no easy way to tell. So what we'll do today is, or the first thing we'll do today is I'm just going to start a new project just for testing, whether we have approaches or ways of doing things that can get around this particular bug. Okay. So sometimes, when the tool that you're using has a bug or something that does not work, it doesn't necessarily mean that you can just okay, it's not working. I'm giving up. There are always, most of the time, there are ways to get around problems. So that's what we'll do today. I'll just name this one, detect closed screen, and so the project name reflects what it is demonstrating. And obviously, to make this work, we're going to add a new screen. So we'll just call it screen 2. In this case, screen 1 and screen 2, those names are fine. I mean, there's no particular need for a particular name. All right, so here's screen 1. All I really want to do is for screen 1 to have a way to know whether screen 2 has closed or not. Okay, because that is the first issue, whether it has closed or not. Once I have a way to detect the screen 2 has closed, we can always use TinyDB to pass information between the screens, so that is not an issue. All right. So to trigger the opening of screen 2, in screen 1, I really just need a button, and I'm gonna adjust the caption on the button to say that, open screen 2, and then change the name of the button itself to BTN, which is just an abbreviation of button, open screen 2, like so. And so the app is pretty simple at this point. Later on I'm going to add some more stuff, like labels, so that we can kind of keep track of certain things in screen 1 while screen 2 is open, and also return some status so that we can see what is happening. Before I go even further, what I'll do also is to start up a virtual machine and also get ADB to start up first. So the first thing we need to do is to start up ADB, the server, in order to start to debug an application. And in this case, I have it installed already under ADT bundle Linux x86 blah blah blah, and it will be under platform. It'll be under SDK and under platform tools. And you can see that we have ADB, the tool here. So I just say ADB, just about, start server, we'll start it, start server. I think it is started already, so it doesn't report anything. And now is a good time to start up the actual virtual machine. To start up the virtual machine, I changed my folder. Well, I can, we can get this one here. And I use another text box to start up the overall interface, which is just under tools. Under tools, there's a program called just Android, and that's my main graphical user interface to start up and configure other tools in the SDK. I mean ADK, Android Development Tools. And here we have Android SDK Manager. The only tool I really need is just manage AVD for the time being, and we'll just go ahead and start the smallest possible device. All right. Yes, it is kind of cumbersome that I have to do all these steps every time I start a debug session, but in reality, when you're developing an application, you start this up once, okay, and then you keep using the same environment over and over again. So the overhead is not really that significant when you're actually developing an application. In a class setting, yeah, because we only have about 80 minutes, so every time we come back here, we have to do this all over again. How many people have a computer that you use for development that you don't shut down like for at least days? Okay, months here. So once you start it up, the overhead is really minimal because you just keep using the same thing, over and over again. And let's see. I'm not. Oh, right there. Okay, it's a little bit slow because in the background it's actually running a virtual machine, running Windows, and that thing is also busy doing things. So that's why today things are a little bit sluggish. Here we go. So once the virtual machine or the Android virtual device AVD is up, I can go back to the command prompt, go back to the prompt where I have the path already to ADB, and I can just run ADB devices, and here I see the emulator 5554 as one of the devices already attached. So that means I have the whole environment set up. I have ADB server up and running, I have the virtual machine up and running, and now I can just do the usual debugging tool or debugging approach. Just start to write code. When I'm all done, when I need to test the program, I go to package for phone, and then use download to this computer, and then use ADB to upload the application, install it, and then I can run it inside the virtual device. For those of you who have an actual device, the process is a whole lot simpler because you can just use Wi-Fi to connect your PC to your Android device, and that makes debugging a whole lot easier, much more streamlined. But this way it still works. Yep.
Is the router connected?
It is.
Well, I see a signal, but it just boots me out.
I don't know. I haven't done anything to it. It started already. It's reporting the Wi-Fi portion is definitely up. I just turned it off and then turned it back on again.
Okay, because I was just getting unable to connect to the seat.
Yeah, I just turned it off and turned it back on again. There we go. So shortly you should see it again and see whether that reset actually fixes it. All right. So at this point I want to just make the program as simple as possible, because in this case I just want to see if there's a way to get around the problems that we saw. So get into blocks. I will go to screen 1, go to button open screen 2, and use this as a trigger to open the other screen. When you want to open another screen, it is listed under control. Scroll almost all the way to the bottom, and it would be open another screen with start value, or just open another screen. You can choose either one. In this case, because I'm only concerned about whether I can detect the other screen has closed, I would just use the simple one, which is open another screen. And in this case, I need to know the screen name. The screen name is, I think it's just screen 2. Now it is case sensitive, so you have to use uppercase screen 2 if the screen has a name of uppercase screen 2. If you type in lowercase screen 2, when you run the program, it's not gonna like it because it won't be able to find the screen that is named lowercase screen 2. So in this case, it is important to use uppercase screen 2. And that's it. I mean, screen 1, doesn't really have much to do at this point. So what I'll do is I'm gonna switch to screen 2. And in screen 2, it doesn't really have to do anything either. I only have to get control over what happens when the screen is closing so I can use that opportunity to put something into the TinyDB and let screen 1 know that, hey, I have just closed. Okay. All right. And here we go. We'll go ahead and look at screen 2. When you look at screen 2, it has all of these events that you can deal with. Typically, when you press a back button and there's nothing else that you can back up on that same screen, it's time to close that screen. So I'm going to use this as a trigger to close this screen. So I'm going to use this one. And when I close the screen, the actual action of closing the screen belongs to control. So once again, we scroll close to the bottom of this one, and then we choose, close screen here. But before we actually close the screen, we also want to, store something into TinyDB, because that's the only one thing that the two screens can see, at the same time, or the simplest way to let two screens communicate with each other. To make use of TinyDB, we have to switch back to the designer, and then drag and drop a TinyDB into the application. And then we go back to blocks here, and we want to look at TinyDB1, and it's time to take a look at, okay, so what do we want to do with TinyDB? I mean, what kind of indicator do we want to use so that screen 2 can communicate with screen 1 and say, hey, I have just closed. There are many ways to do this. It depends on how you want to do it. So let's go ahead and take a look at, let's see here. I would use, I would just increment a counter. In other words, I would have screen 1 to store a value into one of the items in TinyDB. When screen 2 is closing, it would take that number, change it, add 1 to it, okay, and then store it back into TinyDB. So this way, when screen 1, has started screen 2, right before it will store the value before, and then it will keep monitoring that value until it changes. Okay. So we'll take a look and see, how this can be done. Obviously, this requires coordination between the two screens. They must be using the same tag in this case. So I will just go here and say, call TinyDB1 store value. The tag has to be consistent. Whenever I need to use a consistent tag or a consistent name, it's always a good idea to go to variables and use a global variable to specify the name of the tag, in this case, TinyDB tag. So I'll just call this one str, which is the prefix of a string. So this is a string that names a particular tag. So it's a string of a tag of close screen 2. Okay, you don't have to choose something that long, but I just wanted to do it this way. And it's going to be just regular text, and you can use anything as long as it is an agreement between screen 1 and screen 2. It's okay. So I'll just choose here and say screen 2. We'll just call it screen 2 counter. Okay. So once I have my global variable here, I can use it as my tag, and as my tag, I'm going to say variable. Okay, get variable. I only have one global variable here. The value that I want to store is not just what I'm reading back from TinyDB1. It's going to be 1 added to what I am reading back from TinyDB1. So what I need to do here is to go back to control. Nope, excuse me. Go to math first, because I have to think in the opposite way. We have to specify the addition first, and then we go to TinyDB1 to get the value based on that particular tag. So this tag is going to be get variable, and we'll use the same global variable name here. So if I do it this way, it's not possible for me to make a mistake where I'm storing the value to a different tag. So this way, they have to be reading the same tag and storing to the same tag. I cannot have any discrepancy within the screen. Now I can still have one discrepancy between the two screens. That can still happen. But at least, in this case, I don't have to worry about it.
Can you add something that does to something that does not exist in TinyDB?
I think if you have something that does not exist and you try to add one to it, it becomes one.
Okay.
I'm not 100% sure. That can be tested pretty easily. So we'll go ahead and specify this item here as math. It's just a number, and we want to change that number to 1. All right, so now we have the back button of screen 2 already handled, and we want to kind of address the question. Okay, when we read a value that does not exist and add one to it, what's going to happen? Is it going to crash? Is it going to just store 1 into TinyDB? What is it going to do? Well, we can test it. Okay, the program is pretty much done to the point where we can test that part. At least whether it's going to crash or not. If it doesn't crash, I'm pretty sure it's 1 because it's just an empty value to begin with. So if it's a null value and you want to interpret it as a number, as a value, it's probably going to be 0. So we'll do it first. Download this computer, and it's doing the compilation. And I'm just going to check on my virtual machine on the other side. Yeah, this one seems to have everything done. Nice. Okay. And now we have the bundle SDK tools, and we want to run Android in the virtual machine. But we'll do that later. Okay, so the APK file is already downloaded. This is downloaded to my default download folder. I can switch back to my command line prompt and then use ADB to upload and install the program. So I'll just use install-r, in case it's already installed. Well, in this case, I know it's not installed yet, but if I do it this way from the get-go, next time I just need to press the up button to repeat the command. And then the location is going to be the home folder, which is represented as a tilde symbol in Linux, and it's going to be in my downloads folder, and then the name is detect close screen. So there you go. All right, so now the app is installed. I can switch to the virtual machine or the virtual Android device. Go to the applications, and the interesting part is using that way to start the Android virtual device. It's actually persistent because I installed the DBG diary tool, the diary card last time, and it's still here. In other words, that is actually persistent, which is kind of useful in a way. But this time I just want to use detect close screen, open screen 2, and then use the back button to close it. Yep.
Is it persistent because you created that emulator using the ADB tools?
Yep.
Okay.
And there's an option there too. You can actually make it not persistent if you do not allocate that space.
You can also wipe it as well.
Mm-hmm. All right. So it gave me an error. Okay, let me just do it real fast here. So it basically complains that the addition operator cannot apply to a non-numeric value. So when a tag does not exist in TinyDB, it will register. It will basically cause a little bit of a problem. Okay, well, that's good to know. But
Boolean-wise, it will come up as false. Boolean-wise, it will come up as false.
Okay, that can be helpful in a way, but you don't know whether it is actually false or it's just non-existent.
Yeah.
Well, could you initialize the value? Could you initialize the value so that
Yeah. In this case, it's not it's a non-issue because in screen one, I'm going to put the value into TinyDB to begin with, because it is TinyDB, it's screen one who needs to know that value. So screen one has to do it. It's just that if it's not consistent, then we have a problem. The name is screen two counter. So when we switch to screen one, we just have to be careful to use exactly the same thing. All right. So here's screen one. Before I open the other screen, it might be helpful to either initialize the value inside TinyDB to a particular number, or take note of what it is supposed to be. Okay. So you can choose one or the other option. I would just go ahead and initialize it to a particular value. So in screen one, from time to time, quote unquote, from time to time, I can check and see whether that value has changed. So in screen one, I have to go back to designer to include a TinyDB one. So even though I have one TinyDB one in screen one and one TinyDB one in screen two, they are both connected to the same storage on the device. So even though they are different components, they're still connected to exactly the same TinyDB in the back end. Yep.
Regardless of name?
Regardless of name. Because there's no option here you can change. You can probably change the name and it will still be the same. In fact, that's a good question. I think it's independent to the name, so we just call it TinyDB2 in this case. Okay, we'll see whether it still works. Going back to blocks, the first thing we do is to go to TinyDB2, store a particular value related to that tag, and once again, I'm going to variables and create a new global variable to reflect to store that name. Screen tag. Did I use close screen too? And it will also initialize that to some text. The text is going to be this part has to be exactly the same as before. So it's going to be screen 2 counter. All right. And now when I specify the tag, I can just choose the variable. So I can say get variable or get str. No, I can't get it. And the value that I'm going to store is just a simple value. We can just put a 0 in this case. And once my application is like this, I should be able to avoid that problem that we had before, because the problem was only because there's no entry in the TinyDB corresponding to this name. Now that screen 1, make sure that entry exists before starting screen 2. Screen 2 should not have a problem updating the same value. All right. So let's go ahead and try that again. And you can see that I'm doing the same thing over and over and over again. In fact, I'm going to change my browser here so it let me specify. I don't need that. We'll just leave it the way it is. But I'm doing this program, I'm making this program only very in slow and small steps, because this way, if something doesn't work, I know it has to be, the limited number of stuff that I was doing in the previous step. In a regular programming class, how many lines do you guys write before you test the program again? A single function?
Yeah.
But that depends on the length of the function, doesn't it?
Yeah. Usually about every 10 lines I try to test.
Okay, well, I tend to do it, to a point where it can be tested, because there are places or there are stages in the program where it's kind of in between something and there's no way to test it, so I cannot do anything about it. But as soon as I get to the point where, okay, I think I got this condition handled, then I can test only for that condition.
Usually what I do is write the framework, everything that I want, and then I comment out whatever isn't going to work. And just test it as well.
Yeah. All right. So we do have the second file already downloaded, and we'll go ahead and test it again. this time the file name is going to be not the same. It's going to be the one with open paren1. It's already uploaded. Go back to the emulator. Nope. I want to look at the clock. And we'll go ahead and open the application again. Open screen 2. Press the back button. No error messages, so that's good. You know,
and
that
they must be connected. And they must be connected regardless of name.
Yep. And it also means that you can only have one TinyDB for each application. Okay, so now that we have this part working, the next thing we want to do is to say, but how can, from the perspective of screen 1, it doesn't know that it is now the current screen again, and screen 2 has closed. So if I want to do something special when screen 2 has closed and we are back to screen 1 needs to detect it. But remember, we cannot rely on the event that was supposed to work. The event that was supposed to work was this one. When screen 1, dot other screen closed, it would get triggered. But this time it doesn't get triggered. Okay, we tested that already. It gets triggered, but at the wrong time. Okay, this event gets triggered as soon as screen 2 is created, which is not what we want. Okay, so it sounds like we have a bit of a problem here. But what I can do is I can try to get around this problem by using a clock. Okay. Now, the reason why I can kind of try to do this using a clock is when you have a clock, it has basically a built-in timer feature. A timer feature is really useful because what it means is you can execute some code every so often. In this case, it is specified to be 1000 milliseconds. 1000 milliseconds, which is specified here, means 1 second. So every 1 second, you can specify some code to execute. And I can now use that code to detect whether screen 2 has closed. Okay, so let's go ahead and see how this works. I go to the blocks of screen 1, and this time I would use a method or an event in clock 1, and I'll say when clock1.timer do the following. The following is going to be just checking in TinyDB2 whether that value has changed or not. Now, to make this timer not to work, when until we need it, we can always turn it off, before the click. In other words, by default, when I go back to the designer, I can turn off timer enabled, which basically means it's not going to click. Okay, it's not going to generate the events until such time I enable it. Now, if I go back to blocks, as soon as when I click
to uncheck timer always fires.
Say again?
Timer always fires. Do you want to uncheck that?
Yeah, that one is okay. It doesn't actually do anything until it is enabled. So enable is kind of like the global switch. The other one is basically saying, do you want it to fire only once when you enable it? Or do you want it to recur when you enable it?
Okay.
All right, so in here, before we, open the other screen, we can now, turn on the timer. To turn on the timer, we go to clock 1, and then we say, it's a set block here, and we are going to set timer enabled to true. So go to logic, drag true over here. So this way, when we open screen 2, timer 1 of screen 1 will get enabled. Okay. Now inside clock 1, we can now try to do some detection. To do detection, what we need is in a control block because it's a conditional statement. If something happens, we'll do it in a certain way. We'll respond in a certain way. If it's not the case, we'll respond in a different way. In this case, we'll have a conditional statement, an if block. You can always specify. The nice thing about App Inventor is you can always specify the else later on. instead of having to decide whether you want the if or if else, you can always just use an if block and then specify else if or if else later on, which I think is a really nice feature. Okay, so what we want to detect here is whether the TinyDB entry of screen2 counter has changed from 0 to something else. Okay? So what we'll do is we go to math here and we check for inequality, or just equality or inequality, because you can always change it later on. So we'll check for inequality here. The other side of this is going to be 0, because 0 is the original value. And then we go to TinyDB2 and use the value to check it. Okay. So when you're looking at this block here, it is basically just checking every 1 second. It is checking to see whether the TinyDB entry that has a tag name of screen2 counter is non-zero, because it was initialized to 0 before I get to screen 1. If it becomes non-zero, that means screen 2 has just closed in the past second. Okay? If it is remaining as 0, then there's nothing to do, because that if it's remaining as 0, that means screen 2 is still active, and I'm not even 100% sure whether screen 1 gets the tick or not. If it does not, it's okay. If it does, it's okay too. It doesn't really matter in this case. It's not going to take that much time to execute this kind of code. Now, when it is non-zero, then I have several things to do. One thing I can do is I just have to reflect that screen 2 has closed. So the quick and dirty way to do it is to change the caption on the button. That's one quick and easy way to do it. But if you want to do it, not so quick and dirty, the other way to do it is to go back to the designer, go to other stuff, and then drag and drop a notifier into application. Then you can use a dialog box to report, yep, screen 2 has closed. Okay, so that's slightly more proper way to do it. But since this program is not really, it's just a test program, so either way it's going to be okay. So I'm going to go to notifier 1, and then we'll go to, we just need a very simple thing. I think this one is simple. Okay. You just need to specify 3 text blocks here. And the title is the timer sets, and then the message is screen 2 just closed. Go. Okay, now if I don't do anything at this point, every second I'll get this message, because for every second it will test the same condition, and then for every second the condition will be true, and as a result the notifier will will try to poke me every second and say, hey, screen 2 has closed, screen 2 has closed, screen 2 has closed. Probably not what I want to do. So what I need to do here is to borrow this code here and stash it over here. In fact, I'll stash it, no, not there. This would be a good place to put it, because I can just disable it at this point. I don't need it anymore, okay? I just need to detect screen 2 has closed once. So after that, I can turn off the timer so it can stop checking, because I don't need it to check anymore. All right. So I think we got everything that we need, to test this particular approach. It's time to download it again. And before we do that, I'm going to configure my browser not to, rename it. I wanted to. Ask me where to download. So we go to. Advanced. Ask where to save, because I can then use the same name to save it, and then I don't have to change the name to upload and install. Okay, let's go ahead and download to this computer. Are there any questions about the approach that I'm taking right now? There will be a delay. I mean, it's not instantaneous. Screen 1 cannot detect the closing of screen 2 instantaneously, but it's still pretty good, because at least we can do it. I mean, it all depends on the frequency of checking. If you set up timer 1 to check every 100 milliseconds or 10 times per second, then it's going to respond like, just like that. I mean, a 100 millisecond delay is usually not very detectable, unless you're gaming. And somebody else threw a fragmentation bomb at you, grenade. And you go like, no, 100 milliseconds is too long. All right. So let's go ahead and replace that. Go back to my command prompt here and re-upload and install the application. Then we go back to the emulator and rerun the application in screen 2 and close screen 2, and the timer says screen 2 just closed. So now we do have a way to detect that screen 2 has closed, to basically overcome a defect of the environment itself. So are there any questions about this approach?
Suppose there were no defect.
Huh?
Suppose there were no defect.
Uh-huh.
You wouldn't have to do this.
Then you would not have to do this. Then you can use the close screen closed event, to detect that it has closed and handle it that way. But this is still, a way that's workable. I mean,
And this is the first time I see a compile step. Did you have to produce the APK file?
we have been using that approach for a while.
I've never seen a compile window before in this class.
What compile window are you talking about? The black screen right there?
Compiling 20% done, 100% done.
I think we have done it like at least three classes now.
Only for what?
3 classes? Like the previous 3 or 4 classes. We have been using new blocks or the new version of App Inventor for a while.
Compile step and have no compile
Well,
step.
we have done it for several classes already.
Okay.
And I got everything recorded, so we're all good. Yep. Alrighty. So are there any questions? Now, the other question is it repeatable? Okay, if I do this again, can it still work reliably? Do I have everything set up for this to work reliably? Because I have to reset the number, remember? Because if I don't reset the number, it's not going to work. Okay, so I'm going to go to the screen, open screen 2 again, and then close it. And it's almost instantaneous. So I have the feeling that the timer of screen 1 stops when we switch to screen 2, and when we come back, the timer starts immediately. That's because it cannot be coincidental,
Yeah.
right? Okay, to check that theory, now I'm curious. To check that theory, that's an easy way to check it. I go to the designer. Well, I could have done it the other way too. I can change this to 10,000 milliseconds, which is 10 seconds, right? Because, you can say, well, a 1 second delay, we cannot really possibly detect it, right? Or maybe not. But 10 seconds, I think we can tell that 10 seconds has passed. And the chances of landing on, right on the 10-second interval is pretty slim. Okay? So this is one way for me to kind of check and see whether the hypothesis that the timer is restarting immediately when we come back to screen 1, this is one quick and easy way to check it. Because if that is the case, it's really nice because, I may not even need the recurring. I just need it to fire once. And it's not going to chew up a lot of resources because it's, it's not going to run all the time. All right. switch back to device. Oh, no, I have to reinstall it first. The reinstall process is going to restart the application. No, I shouldn't say restart. It will close the application on the other side. So when we switch back in, so you can see that it's closed already. We can restart it. Open screen 2. Go back. Okay. So it is, going to take some time. Yep, there we go. And we can actually detect it too. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. All right. Well, I would still say that we have a way to detect the other screen has closed. So change it back to 1,000 milliseconds. It seems to work okay.
You could have it less now, since we know that it will just pause the execution of that screen. So you can put like half that, quarter that.
Well, we can also detect that too. We can actually, so the question is, when we have screen 2 opened, does the timer of screen 1 keeps ticking, or does it stop, until screen 2 has closed and then it resumes the timer of screen 1? I think that's a valid question. Okay, I think the timer keeps going, even when screen 2 has opened.
When we were doing the 10-second test, you waited for about 3 seconds, then clicked it, waited 3 seconds in the second screen, then went back, and when you counted to 10, you counted past 10 to 13. That would include the time that was paused.
So the thing is actually pausing the timer.
Mm-hmm.
Well, that's a easy way to test it. Okay, the easy way to test it is just to include a label. Okay, so we'll include a label here, and the label text is just going to be 0, so it can be interpreted as a number as well as text. Okay, and then in the code inside the blocks here, we'll go to the timer block, and regardless of whether this test is successful or not, we are going to increment that value. So we'll go to label 1, and we use the set label text method, and then we'll use math, use the addition, and we're going to add 1 to the label's current value. So we go back to label 1, and then this time we get the text value of the label. Okay. So we'll give it a try. I mean, this is really the only way that we can test to see whether it is working or not. So we'll package and download to the computer again. The reason why I think it might be taking in the background, or the events are still happening, is because when we first use the other screen closed attempt, it happened immediately. We could see the notifier box appearing right before we get to the other screen. So that's, to me, that means it's not actually shutting down its processing of all the events. Is still actually processing, but whether the timer is still going or not, is a separate question. Because it can go either way.
I just thought of that like as a special handle.
Possibly. Okay, so we open up screen 2, and then we wait a few seconds. Okay, we have to wait a few seconds, for the timer to accumulate several clicks, and then we close it. We go back to the first one, and it has updated. So it does take in the background, which can come in handy too. That gives you certain options as well.
So it's processing more than one screen at a time.
They're simultaneous. when you open up multiple screens, the different screens are actually, they're called activities, by the way, in the official language. It's called, each screen is an activity, and they're all parallel. They can all be doing things at the same time. So that means, when screen 2 is open, screen 2 can do things that does not require user interaction, like computations, updating certain things on the screen, stuff like that. And by the time screen 2 closes, it can go back to screen 1, but screen 1 has changed already. In a way, it makes sense because when you use the phone itself, okay, on Android, okay, I'm just going to do it here. So when you use the phone feature, let's say you are on the log originally, the middle one, that displays the call log, and you place a call, okay? And if during that time, if something happens, I think the call log gets updated in the background. So I think each screen or each activity, gets its own, events, and it doesn't stop when you're on another screen, even though it's the same app.
So can you manipulate display elements on screens that aren't open, or is it just the process?
But you won't be able to see it because the others.
Back, right?
Yeah, but that's exactly what happened.
Yeah.
Yeah, because this screen. Okay, if I do it again.
Try to change the label on.
Yep. So it actually it's being updated in the background. Now we can never really quite see whether it's actually updating in the background or everything just gets updated when we come back. But we know the code is working. We know it's incrementing, right? And the incrementing code is not doing anything. I'm not using a global variable to keep track of the counter. I'm actually using the label, as a counter itself. So that means, the update of the label is actually happening, quote unquote, in the background when screen 1 is not visible anymore. All right. But I think, even using a 1 second delay, it's not bad. I mean, it's almost instantaneous. So I think it's fine.
It's a little too instantaneous.
Huh?
I was just saying, when you click back, it was nearly instant.
Yep. It's close enough,
Yeah.
But we can see that, with a 10-second delay, it's definitely detectable. So 1 second is not bad. I mean, it's not chewing up a lot of processing resources. All right. So do we have any questions about this little, experiment? No questions? I'm going to upload it.
Can't we expect an upgrade to correct this defect?
I guess eventually, but we don't know when that's going to happen.
Could be today.
Could be today, could be sometime later,
Next
But
year.
now we have a way to get around it.
Next year.
Next year could be, It's open source, so, we can actually go in and actually fix the source code. But then we will have to host, App Inventor 2, to run the modified code.
Would the open source have the necessary keys to interact with the compiling on the App Inventor servers?
I think you just run your own, server, so you'll be using your own compiler. So it's you will no longer be using the MIT server for compiling, which can be good because then we can have a server that is only accessible to this class, and it won't be loaded by other people using App Inventor. Right. So this is good. This is definitely good. What I'm gonna do is I'll do this right away before I forget. So what I'm gonna do is to go here and click this project. This is also kind of interesting, because in case no one has noticed, all the uppercase projects are listed, before the lowercase projects, and that's because uppercase characters have lower or smaller ASCII values compared to lowercase. That's a Linux thing. In Windows, lowercase and uppercase are interchangeable, quote unquote interchangeable. It's not case sensitive, but this indicates that the software is case sensitive. Kind of interesting. Download source. put it into my downloads folder, and then I go to the gallery, upload it so that you guys can download it and have it for reference. Okay, I need to sign in as Dr. Tag 2013, and then we can go to My Apps, add a new application. I can type. Okay, description is App Inventor 2 as of November 4th of 2013. Has a bug that makes the detection of other screen closed. This app uses a timer and TinyDB to accomplish the same thing. Okay. Application. Oh, I forgot to make screenshots.
Screenshot of the button.
Okay, go back to the. Okay. Does it have a built-in screenshot button shortcut?
Oh.
It probably does, but it's okay. I can just use the system-wide screenshot. Huh?
Oh yeah.
Oh. No, I'm trying to see whether the AVD has its own screenshot ability. I know Android 4.3 has a screenshot ability. I think it's holding down the power button and also one of the volume buttons at the same time, and it do a screenshot. It puts it into the gallery. But since this one is not set up, to do any outgoing traffic, that's not going to help me because it stays on the device itself.
Yeah, it's home and power button.
So, say
Home
again?
and power button.
Uh-huh.
That's the screenshot.
Okay. But that's not going to help me. And I just waited too long. The other screen has dimmed down. Okay. Do that again. Screenshot. There we go. Okay. Save it. Over to here. Select image. Specify the screenshot. Tag. Bug. Other screen closed. Timer. TinyDB. Save application. All right. So now it's up. You guys can download the application if you want to, just for your reference. If you want to use App Inventor 2 and you need to detect, one of the screens has closed, this way you can do it. The communication between the screens can also be done using TinyDB. It's kind of abusing TinyDB because that's not what it's designed for, but nonetheless, it is a way for one screen to pass a value to the other screen because they share the same TinyDB. Right. So are there any questions at this point? Yep.
We actually start using Java code to start making apps. Well, is there something built in so you don't have to use TinyDB to share information between screens?
When you're using actual, yes, because in that case you'll be using object-oriented programming. And I think that between the screens, it's still an event. Okay, when a screen that you open has closed, it is still going to trigger an event, but it's going to be able to pass information back much more natively. App Inventor is supposed to have a more, kind of more integral way of passing information back, but it's just that part is not working at this point. Any other questions? All right. If there are no questions, I'm going to my Windows virtual machine. This is my other virtual machine that's running. That's why the PC is running a little bit slower today. Okay, so this is in Windows XP. The same virtual machine that I was using on the other day. I just finished installing a few components. I installed Java. I installed APK tool, and I also installed the Android development kit. So at this point, I can run the Android development kit, and it displays the same thing. So it's basically the same thing that I've been doing in Linux. It's just that now I'm doing it inside Windows. But it's basically the same thing. How many people have set up all of these tools at home already? So you're basically running the same kind of tools at home. Okay. It says it's done, but it's not. And I can also create AVDs just like on the other one. So basically, there's no real differences between using Linux versus using Windows. The commands are slightly different. The way you navigate will be slightly different too. Okay. Any questions? No questions. How many people are planning to run your app in different resolutions instead of using the really fuzzy resolution that that App Inventor defaults to? You're changing the okay. So do you have the tools installed on your machine to handle the different sizes? Not yet. Are you using Windows or are you using Linux?
I have boxes for Linux.
Say again?
I have both.
You have both? Okay. All right. So what I'm going to do is I will show you how to do that in Windows, because Windows doesn't come with many of the tools that we need to get this done. So we have to basically install everything, over here. Okay, now I got most of the stuff already installed here. So let me start my command prompt so I can show you how it's all set up at this point. Okay, I installed all of my tools under just my name or in documents and settings. That got changed to users, in later versions of Windows, but in earlier versions of Windows, including XP, it's just called Documents and Settings. And you can see the two folders. One is ADT Bundle Windows x86, blah blah blah. That one includes everything in the Android development kit, the Android software development kit. The other one is APK tool, which has basically 3 files. So if I go to APK tool, it includes the 3 files here. So go to this folder. It has these 3 particular tools or programs or files. APKtool.bat is really just a batch file. All it does is to use Java to start up the jar file. In fact, if I type it, the type command is going to show the content of a text file. That's all it is. I mean, it's just really starting up Java using Java to start up APK tool, which is a Java program. Okay. So using this tool, okay, let me switch back to Linux, okay, because switching back to here, I can show you the tools that I already have installed here. So let me go to APK tool here. Nope, that's not. APK tool here. Okay, 152. cannot remember where I installed APK tool with all the other stuff here.
It's under TAC APK tools. Oh wait, that's
I thought it's just APK tool. I created a file to sign to. Okay, I'll just look for that file.
Oh, looks like it's right there.
Yeah.
Middle column.
Sign.sh. No, but I have multiple, you know.
Yeah, last one you were
APK
using
tools.
was apktools.old.
.old. Okay. Okay, you're right. Okay, so we got everything here. So what I have here that is a little bit special is some of the executable. AAPT is already here, but there are zip align. You know, it's not. Okay, you know that's a different file that I had to download. Not sure that it's actually needed. Okay, if I look at update, that shows me all the files that I need. So APK tool, sign, and zip align are the files that I need. And then sign itself is using jar signer, which is a Java tool. So I need to replicate, you know, basically the same thing in Windows, you know, to make that work inside Windows. All right, so so I need to replicate the same type of files over here. Let me see if I can find jar signer. I don't think it's recognized here because I need a full path to Java to find it. Okay, so let's go ahead and find it in Windows. Okay, in Windows, you know, the files are installed in program files. In this case, it's Java, and it's JRE7 under bin, and it's JRE signer. Doesn't have it. I think I need to install the full Java and not just, you know, JRE.
So for the App Inventor key store, just download that, then use it with the signer.
Yep. I just used that particular key. You would need to know the password. The password is just Android, all in lowercase. All right. I have to get. Not JRE, I need the full Java in this case.
JDK.
JDK, that's right. Windows operating system.
I'll just go Google search JDK, download.
Yeah, well, this one is definitely just JRE. That's going to take a while.
Save it.
Okay, we have to pick the Java SE development kit.
123 megabytes.
Yeah, we want Windows x86. Alright. Well, it's not the download, it's the installing part that's going to take a while. Because I'm doing it inside the virtual machine.
And it's really in the virtual machine, I don't see it taking that long. It's just the access to the hard drive.
And this is going through USB 2.
bottleneck.
Yep. Let's wait. All right. Oh, by the way, I went to boot the last night, and there's another tablet for $99. Okay, so let me see if I can find it. I think it was listed under. Ooh, Kindle Fire, but that wasn't it. Let's see. Media players. I think these will work too, because they're all Android based. So even this one, it's an 8 GB digital media player. As long as it has Google Play, it should still work. So it looks like it has, all the Google apps already installed. So for $75. This one probably work because it does have Android on it, and you can download and install anything in Google Play, so it's basically open enough. We just have to make sure that it has the developer options open too, because otherwise you can't really easily get your app onto the device.
Are some devices locked down so you can't just enable the hidden menu? Or is it just hidden and you just have to know about it?
Yeah, Chromebook is locked down, but the other ones have to switch it back.
Okay. Yeah, but this one is different. Okay, this is what I would do. I know some of those devices listed here, they are rooted already. So anything that is rooted, you can always install, CyanogenMod to make all the options available. It's basically, okay, when you look at this, it's basically iPod, okay, but Android. It's an Android, quote-unquote, iPod. But it's also inexpensive enough, for purposes of this class. That's definitely, I think, it's a viable option. I haven't bought one yet, so I don't know exactly whether it's gonna work or not. But it looks like it's gonna work. Switching back to the virtual machine. Oh, it's done. Oh, it just gave me the next button.
Got done pulling the system.
Not quite done yet. Right. How many people have a native device, like a physical device for programming and debugging? So the rest of you are using virtual machines? Okay.
On the device you just showed us there, what is the 3.6 dimension?
It's diagonal. So basically from here to here is 3.6 inches.
The other is 4.2.
Yep, the bigger you get, the more expensive it gets. Don't get this one. I have it. It's not. Yeah, one. It's not Android. If you want to, just use it as a media player, it's okay, but it's not an Android device. Is useless for this class. So if you want to use something for this class, it has to be Android based, and these three options are Android based, and I think at least one of these are rooted already. So there's a CyanogenMod version of it. I thought I saw something else, that's also a tablet, but I couldn't find it now. Maybe it's under this page here. No, not there. No, Java is still installing. those of you who are going to run a virtual machine, do you have a relatively fast computer? Okay. Okay, I have successfully installed Java's SE development kit. Next steps. Okay, I don't need anything else, so that's okay. Okay, all right. So now we have to go back to Java, and this time I have JDK 1.7.0 installed. So go there, go to the bin folder, and this time I should see JAR signer. There we go. So we do have the application here. The problem is the executable is not, you cannot just run it in any folder. So if I switch back to my command line prompt here and type in the name of the executable, which is jar signer, JARSIGNER, it's not going to run because the path to the executable is not exposed. So you have several options here. Okay, there are several options. One is just write a little batch file, which is probably the easiest way to do it. Okay, so I would just use Notepad here to write a little batch file to do exactly what I have, on the Linux side as a, as a shell file. So I'm gonna run, update.bat. It has to have the extension .bat. Yep, gonna create one. And I'm just going to mirror, what I have, on the Linux side, on this side here. So the sign script is really just this. I can, deal with that later. So if I look at, update.sh, everything that I have here, I can basically mirror just about everything here on the other side, except I don't need the first line, the pound exclamation point. I don't need it. And then the other part is, I don't need a / in front of APK tool. I just say APK tool because it is in the folder where the executable is located. And then the path to the APK file is entirely up to you. So you have to kind of substitute with where the path where you will be downloading the APK file. But other than that, we can basically mirror exactly the same thing in Windows. So I'm gonna type in here. So we just have APK tool decode -f, and then this part is entirely up to you to decide where you want to find the APK file. If I remember correctly, %1 refers to the first parameter to a batch file. Is that correct? In Windows.
As far as I recall, yes.
Yeah. Okay. So we will just use the %1 for that. Okay, the second one is patch. Okay, we don't have patch in Windows either. So if you want to use patch, which I think is a great way to do it because it's just quick and easy, you don't have to actually edit the file. You can download patch and install it. So if you go to any browser in Windows, you can just look up Windows patch. And the first link is the one that you need. It basically just installs the executable of the patch utility program into Windows. And once it is installed, okay, I have installed it already. Let me just, show you where to find it. Once you have it installed, you can use. I'll just open another one. Go to My Computers. Go to the C drive, Program Files, and this time it's under GNU Win32. Go to bin, and now we have the patch executable. And then once again, you can see the path to the executable is not in the path variable in the environment. So you will have to supply the entire path to get it to run, which is a hassle, but it does work. Okay, it's not the end of the world to have to do this. So let me go to my Notepad here. So in the path, you will have to specify C drive / program space files / GNU Win32 / bin / patch. Okay, so instead of just saying patch, you have to specify the entire path to the patch executable, which is a hassle, but it's okay, it works. And then you have to supply the additional names. Basically you have to say which file you are patching, and the file that you're going to patch is going to be %1. Oh, I cannot use %1 because that specifies the path to the APK file. I'm just gonna let me just do this a little bit here. There is a environment variable to refer to the user himself, the user account, or the user folder.
Username?
I thought that's one. Set. Okay. See if there's anything here.
Yeah,
Home
username.
path. Home path is one.
It doesn't include the partition. You have to include C. Go on.
Home path is just the folder itself. Or we can just hard code everything, right? Okay, C:\\, in this case it's documents and settings, / downloads, and then assuming this is where you're gonna download your APK file, you just say whatever .apk, but it has to be exactly that name and exactly that path, so we don't have any flexibility in this case. When you run the patch program, you have to run it to whatever which is under the current folder, and the file name is going to be, if I remember, it's Android manifest. Let me switch back to Linux to find that. Yep, Android manifest.xml, and then you have to redirect using the screen.div file. I can upload that to Moodle, so you have access to that. So whatever Android manifest.xml, and then redirect redirect the input from the file, that we will just call screen.div. And then we can do the rest. So the rest is just running APK tool build, and then in this case is whatever becomes your project name, by the way. And then we need to do the sign. The signing part is using jar signer. So if you look at the sign script itself, it's just using jar signer. So in this case, we'll have to specify the path to the jar signer program, which is under program files /java / JDK 1.7.0 _45 /bin /jaw signer. Okay, I think you guys get the idea, right? I'm just replicating everything that I can do in Linux to here, except I have to add the path to it, but everything else we can just do exactly the same way. So we say verbose /keystore android.keystore. We're gonna have to download that from App Inventor. The $1 is the file that we are assigning. So in this case, it's going to be under whatever dist underscore whatever.apk. We don't have to go through the verification, so the second command we don't have to include. And then the last step is the zip align step. Zip align is a tool that you have to download. So you have to kind of set that up, separately. So let me look it up here. Yep. So zip align is a tool that you have to download. Separately. But it's the same steps, it's just you just have to convert, everything to work in Windows. Any questions? No questions? So, Niall, can you get everything done in Windows? I mean, it seems like you're the only one who's going to change the resolution or have to get the native resolution.
I mean, it's no problem for me to just do Linux.
Yeah.
I can just do it in Linux. I have Google on my computer.
Okay. Yeah, even if you do it in Linux, you still have to kind of fiddle with certain things, to bring all the tools together. But it's just a matter. Yep. All right. Sounds good.
I'm still finalizing the design.
Okay. Understood. All right. Any other questions? No questions? Now, you guys really need to be starting on your application, okay? So this is a good question, because somebody needed to detect the closing of another screen. So we kind of troubleshoot and find a way to do that. So if you're working on your project and you basically hit a snag, okay, I cannot get past this point, bring it to the class. So we'll make it a topic, in this class, and I can help you, troubleshoot and get it done. Okay. Any other questions? No other questions? All right. What I will do is probably set up a checkpoint, okay, just so that I can see where you guys are at this point, and then I can probably give you some idea of how to proceed next. Let's make that next Monday. Okay, so next Monday during the lecture, I'm going to just go from one person to the next. And see how far you have gone. You can just load up your app at this point and tell me what you want it to do and what you think your next step is. Yep, go ahead.
We can't get App Inventor 2 to work anymore. I built a whole program and it kind of works in the beginning. Now it doesn't work at all.
Is it App Inventor 1 or 2?
2.
Okay. I can take a look, later on, during the lab time.
I don't know if you just want to do it here.
Say again?
No.
Okay.
I don't know if you're trying to kill time or you want to do something.
No. We are done with the lecture time, so the lab time is that's what the lab time is for. Okay. I'll go ahead and stop the recorder because there's really nothing else